Hello everyone, I'm Pasindu Tennage, and in this video, I'm going to discuss about failure modes in distributed systems. First, we are going to look at the general idea of process failures, and then I'm going to talk about four popular type of failures called crash, crash recovery, omission, and Byzantine. And finally, I'm going to briefly discuss how these failures affect the distributed protocol design. To illustrate, assume there's a distributed setup running with three nodes A, B, and C. So initially, the replica set runs the algorithm. Each node runs a set of algorithmic steps that it's supposed to execute. However, at some point, node B stops participating in this protocol because it just fails. Now, there are multiple reasons for these failures. They can be because of process crash, power supply failure, natural disaster, or human operator errors. Now let's look at the different types of failures which are widely seen in distributed setups. The first one is called crash failures, and the general idea is the process just stops executing at time t. To illustrate, assume in this x-axis, I show the process lifetime. So the process until time t runs without any problem. By running, I mean it executes the set of algorithmic steps that it's supposed to execute. However, at time t, something bad happens, and after time t, as a result, the process does not execute any algorithmic steps. So we call that the process t crashes at time t, and those type of failures are called crash failures. The second type of failures are called crash recovery failures, and in this type of failures, the process continues to crash and recover. To illustrate, assume there's a process that until time t1 works perfectly, meaning the process executes a set of algorithmic steps that it's supposed to execute. However, at time t1, it crashes, and until time t2, it doesn't execute any algorithmic step. At time t2, it recovers, and it starts to execute the algorithmic steps. However, at time t3, it crashes again, and at time t4, it recovers. So this can go forever with the process crashing and recovering. And these type of failures where a process can crash and then later recover are called crash recovery failures. The third type of failure is called omission failure. And the basic idea is the process does not deliver or send a message that it was supposed to send to. For example, assume a distributed setup. Now let's assume some hypothetical algorithm. I'm just coming up with some algorithm just to illustrate this scenario. Now let's assume in our hypothetical algorithm, the first step is for node A to send a message to B and C. And the distributed algorithm specifies that upon receiving a message from A, node B should send a response back to A. Now this is what our algorithm says. Now assume node B does not send this message that it was supposed to send. And we claim that node B is an omission faulty node because it did not send a message that it was supposed to send. So these type of failures where a process does not deliver or send a message that it's supposed to send or deliver are called omission faulty nodes. The final type of failures that we're going to discuss in this video is called Byzantine failures. And the idea is a process deviates in an arbitrary manner from the specified algorithm. Now, this is the most difficult type of failures to address in distributed algorithms, because in this failure mode, a node can do anything. By anything, I mean anything. The node can just change the step, or the node can just execute some random instruction instead of what it was supposed to execute. So there are different ways a node can be doing Byzantine activity, and one such common type is called equivocation. So to illustrate, assume there's a distributed setup with three nodes A, B, and C. Now our distributed algorithm, and again a hypothetical algorithm, it mentions that first node A should send the same message to node B and C. So the algorithm specifies that node A should send the same message to B and C. However, Instead of sending the same message, node A sends conflicting messages to B and C. So node A sends message M1 to B and message M2 to C. So now this is clear violation of the protocol, and we claim that node A is a Byzantine faulty node. So these kind of failures where a process deviates in an arbitrary manner from the specified algorithm is called a Byzantine faulty node. So we talked about different failure modes. Now let's discuss how this affect distributed algorithm design. Now distributed algorithms are designed to tolerate different type of faults. And some algorithms such as Paxos and RAF tolerate only crash faults, but there are algorithms like PBF10 hot stuff that can tolerate Byzantine faults. So the general idea is before you come up with a new distributed algorithm or before you read an existing algorithm, you should first pay attention to what sort of failures that this algorithm can tolerate. Meaning, if the algorithm says that it can tolerate only crash faults, then you should understand that particular algorithm is not going to work if there are Byzantine faults. So the first step is to first identify what sort of failures the algorithm is supposed to tolerate. And the second important thing is to understand the concept of fault threshold. So distributed algorithms cannot provide safety for any number of failures, meaning you cannot come up with the distributed algorithms that can tolerate up to infinite number of failures. So usually the common practice is to state the maximum number of faults. So to illustrate, assume you're going to come up with a new algorithm. So as I said in the previous slide, you are first going to state, okay, this algorithm can tolerate crash faults, or this algorithm can tolerate Byzantine faults. So that's the first thing. And once you specify the failure mode, the next step is to specify the fault tolerant threshold or fault threshold. And there you will say this algorithm can tolerate up to F number of faults, meaning the maximum number of failures that can happen in the entire execution of the algorithm is bounded by some given F. So we usually use this simple F letter to denote the maximum number of faults allowed in an algorithm. So to summarize, in this video, we discuss about the process failures, and then we discuss about crash recovery, omission, and Byzantine failures. And finally, we briefly look at how these failures or failure types affect the algorithm design. See you in the next video.